See, I'm planning to discuss topics like sorting algorithms, which is common for both DA and CSE students, and it is the highest weightage topic in algorithm subject, friends. Okay. So first topic is sorting algorithms, where I will focus on bubble sort, selection sort, insertion sort, merge sort, quick sort, and then heap sort. While I'm discussing heap sort, I'll explain main important aspects of heap tree also. This is also very important topic for you. Okay. And afterwards, next topic is spanning tree. So DA students point of view, this topic comes under graphs, basics of graphs. Okay. So spanning tree, under spanning tree we are having algorithms like Prim's algorithm and Kruskal's algorithm. So you believe me, without having spanning tree question, there is no gate question paper so far. So this is the highest priority topic in algorithm subject. Suppose if the tomorrow is a gate exam, then definitely you have to give first priority to spanning tree and then sorting algorithms, friends. Okay. Next one is shortest path algorithm, which is common for both D and CSE students. That is Dijkstra's algorithm, Bellman-Ford algorithm, and all-pair shortest path algorithm. This all-pair shortest path algorithm also known as Floyd-Warshall's algorithm. Okay. So after that, if we have time, we will focus more on searching algorithms, like how linear search is working and how binary search is working, and what is the difference with respect to time complexity, and what is the difference with respect to recurrence equation. So different aspects we will discuss in searching algorithm, friends. Okay. Next one is time complexity. So if time is there, I will introduce master theorem concept also. Okay. Still, if you have time, we will cover time complexity based on simple loops, and time complexity based on nested loop. So could you please someone confirm that are you able to hear me properly and is everything is clear? The first topic which we are going to discuss, that is sorting algorithm concept, friends. Okay, sorting algorithm concept. Actually, sorting algorithm concept, while I am discussing merge sort algorithm, quick sort algorithm, heap sort algorithm, I need to write recurrence equations. Okay, recurrence equation. That is reason first I will introduce how to solve recurrence equation by using master theorem. Because without having master theorem concept, I cannot explain quick sort, merge sort, and then binary search algorithm, friends. Therefore, first I will teach master theorem, so that you can recall all different cases of master theorem. So with that, we will move to the concept of sorting algorithm, friends. Okay. Generally, this master theorem concept, where we will discuss in divide and conquer technique. Suppose if T of n is equals to A into T of n by B plus theta of n power k into log to the power of Pn to the base B, where A value is greater than 0, B value is greater than 1, k value greater than or equal to 0, and P is any real number. P is any real number means we can allow negative numbers also. P is any real number. So whenever given recurrence equation falls under this category, in that case there are three different cases in master theorem. First case, if A is greater than b to the power of k, if A is greater than b to the power of k, then T of n is equals to, you also think about the solution, friends. Okay, simultaneously you can do the revision. And the second case, case number 2, if A is equals to b to the power of k, and again there are three sub cases are there. First one, p value greater than -1, then T of n is equals to, that is the first point. Okay, and the second point is, if p value is equals to -1, then T of n is equals to, whereas third case, p value is less than -1, then T of n is equals to. right friends. So first case a greater than b to the power of k, second case a equal to b to the power of k. In second case also we are having 3 sub cases, and the third case, case number 3, if a is less than b to the power of k and p greater than or equal to 0, please excuse me, if p greater than 0, then T of n is equals to theta of, so we will discuss what is that value. Next, second one, if p value is less than or equal to 0, then T of n is equals to. Most of the recurrence equations falls under this category. In that case only we can apply master theorem, friends. Okay, there are some situations where recurrence equation not falls under this category. For those recurrence equation we cannot apply master theorem. Clear? So what are the different types of equation which are not falls under this category means? See, just observe. Suppose if you are having recurrence equation T of n is equal to, T of n equals to 2 into T of n by, that is 2n by 3. n by 2 plus theta of n square. Suppose if you have a recurrence equation in this format, if you convert this recurrence equation in the standard format and compare with the constants a, b values, where a equals to 2, a value equals to 2, what about b value? B value is equals to, you can rewrite this equation as 2 into T of n by 2 by 3 plus theta of n square, right friends. So what about a is equals to 2 and b equals to 2 by 3, right. So here a equals to 2, b equals to 2 by 3, but the restriction for master theorem is b must be greater than 1. The reason why b greater than 1 means then only work is divided among the people. Okay, suppose if b equals to 1, it cannot be divided, work cannot be divided among the people. That is the reason it is compulsory we have to take b must be greater than 1. But here b equal to 2 by 3, which is not greater than 1, friends. Okay, so therefore not greater than 1, hence master theorem is not applicable in this case. This is the first case you have to remember. Okay, and the second one, suppose if you take T of n is equals to something like 2 into T of n by 3 minus of n square. Here negative functions are not allowed in master theorem. Negative functions are not allowed in master theorem. So therefore here also we cannot apply master theorem, right. And third case, suppose T of n is equals to 2 into T of n by 2 plus something like theta of 3 power n. It is exponential time, friends. Okay, 3 to the power of n means exponential time, where here we are expecting always polynomial time complexity. Okay, so for exponential time complexity we cannot apply master theorem. Directly I can say it is a dominating value, hence the time complexity bounded by theta of 3 power n only. Here we cannot apply master theorem. Okay, so these are certain cases we should understand where we can apply master theorem, friends. Okay, now we will discuss the different cases of master theorem. Suppose if a greater than b to the power of k, then T of n is equals to formula theta of n to the power of log a to the base b, n to the power of log a to the base b. Suppose if a is equal to b power k and p greater than minus 1, simply write down solution of the first case as it is, theta of n to the power of log a to the base b. Okay, even p is equals to minus 1 also we can write theta of n to the power of log a to the base b. Means if you remember first case answer, second case, third case is so easy. And second case again third bit, it is theta of n to the power of log a to the base b. Clear, friends? Okay. But in second case first bit, if p greater than minus 1, in addition to theta of n to the power of log a to the base b, we will have log to the power of p plus 1 n to the base b. Right, friends? Okay. Here additional term is, it should be multiplied by log n to the base b. Clear, friends? Okay. Here there is no multiplication factor for multiplying them. That's all. Okay. Next, third case, if a less than b to the power of k, if you could remember the statement, from the statement we are having theta of n to the power of k log to the power of p n base b, right? So that case we can write here as it is. We can copy this part as it is. N to the power of k into log to the power of n to the base b. Right, friends? Okay. Suppose if p less than or equal to 0, p less than or equal to 0, p less than or equal to 0 means put simply p equal to 0 in this case, because it is taking less than or equal to 0, right? How you remember this one? Simply put p equal to 0. If you put p equal to 0, you will get theta of n power k, theta of n power k. Clear? So these are different cases in master theorem, friends. Okay. Suppose they may ask the question, t of n is equals to 4 into t of n by 2 plus n into log n. They may ask question like this. Okay. So first to compare this equation with the master theorem. By comparing the master theorem, we can write it as a into t of n by b plus theta of n power k into log power p n to the base p. Right, friends? Okay. So by comparing the standard form, a value is equals to 4, b value equals to 2, where k is equals to, we can write n to the power of k, that equal to 1, right? So k value equals to 1 and p value is equals to 1. Now verify is it belongs to first case, second case or third case. So first one is a greater than b to the power of k. A means 4, b means 2 and k means 1. Yes, a greater than b to the power of k, condition true. Hence it belongs to case number 1. Case number 1 answer is t of n is equals to theta of n to the power of log a base b, n to the power of log a base b. So we can also write it as 2 square, bring square here, log 2 base 2 value equal to 1, therefore hence it is theta of n square. Okay. This is the first question based on master theorem, friends. Okay. Next question, question number 2. Suppose if t of n is equals to 2 into t of n by 2 plus log n, 2 into t of n by 2 plus log n. Again compare the master theorem and get the constant values a, b, k. A value equals to 2, b value equals to 2 and k equals to 0 and p equals to 1. Right, friends? Okay. Now verify the condition is a greater than b to the power of k. Yes, 2 greater than 2 power 0, which is true. Therefore it belongs to case 1. In case 1, t of n is equals to theta of n to the power of log a base b, which equals to theta of n. Theta of n. Clear, friends? Okay. Next, third one, t of n is equals to three into t of n by 2 plus root n. 3 into t of n by 2 plus root n. Just compare the standard form of the master theorem and get values of a, b, k. A value is equals to 3, b value equals to 2 and k equals to 1 by 2, because we can write this n to the power of 1 by 2, right? N to the power of 1 by 2 means k value becomes 1 by 2, but p value is 0 this case, p value equal to 0, right, friends? Okay. So therefore verify is a greater than b power k. Of course yes, because 3 greater than 2 power 1 by 2, which is correct. Therefore we can say it is true. So it falls under category of case 1. Therefore t of n is equals to theta of n to the power of log a base b, that is log 3 base 2. Right, friends? That is the third problem in master theorem. Okay. Next, fourth problem, t of n is equals to 2 into t of n by 2 plus some constant c, If it is constant value c and n to the power of k is absent, log to the power of p also absent. Okay. So therefore verify is a greater than b to the power of k or not. So 2 greater than 2 power 0, because a constant, right? Constant means we can write n power 0, log power 0. So k value is 0, p value is 0. 2 greater than a greater than beta power of k. So 2 greater than 2 to the power of 1. Sorry for the mistake. 2 greater than 2 power 0. Yes, it is true. So it belongs to case number 1. Therefore, T of n is equals to theta of n to the power of log 2 base 2, which equals to theta of n. So these are 4 different types of questions in first case of master theorem. See how I explain this problem. In first case, both k and p are present. Both k and p are present, right? Where in the second problem, k is absent, p is present. Third problem, k is present and p is absent, right friends, okay? And fourth one, both k and p are absent here. In this case, both k value equals to 0 and p value also 0, because we can write it as n power 0. Therefore, by comparing with this master theorem, we have a equals to 2, b equals to 2, and what about k? K equals to 0 and p equals to 0. Right friends, okay? So whenever you find any question in master theorem, first verify if it belongs to first model, second model, third model or fourth model. Clear friends, okay? Problems based on second case. The problem number 5. T of n is equals to 4 into T of n by 2 plus n square into log n. 4 into T of n by 2 plus n square into log n. Just compare the master theorem. You will get a value equals to 4, b equals to 2, k value equals to 2 and p value equals to 1. N to the power of k, log to the power of p, n. Here base is not required to show every time, because in algorithm subject base is not having any impact, okay? Because for example, if you write theta of log n base 2, why we are not focusing on base means we can write it as theta of log n base 2 means we can write it as log n by log 2, correct friends? Log n by log 2. Log a to the base b we can write log a by log b. In the same way, log n base 2 means we can write log n by log 2. But within asymptotic notation, there is no importance of the constant log 2. Therefore, it is reduced to theta of log n. That's why no need to give importance of this base. Okay, you don't give importance of that base value. Right, verify is a is equals to b power k or not. 4 is equals to 2 power 2. Yes, a is equal to b power k condition satisfied. Then it belongs to case 2. But under case 2 again we are having 3 sub cases, right? So therefore, p is equals to 1 means which is greater than minus 1. P value is greater than minus 1. So therefore, it belongs to second case. Under second case it is first bit. Therefore, T of n is equals to theta of n to the power of log a base b into log to the power of p plus 1. So, p plus 1 means 1. 1 plus 1 log to the power p plus 1 n base 2. Clear friends, okay? By simplifying, we will get result as theta of n square into log square n base 2, because log 4 base 2 means we can write it as 2 square, we can get 2 here. So, n square into log 2 base 2, log 2 base 2 value is 1. So, this is the first one. Next, sixth question. T of n is equals to square root of 2 into T of n by 2 plus square root of n into log power minus n base 2. Right friends, okay? Now compare this problem with the standard theorem of the master theorem. Now a is equals to square root of 2, b equals to 2, k value equals to 1 by 2 and p value equals to minus 1. Right? Therefore, verify is a is equals to beta power of k. So square root of 2 is equals to square root of 2. Yes, a equal to beta power of k condition satisfied. And p value exactly equals to minus 1. Therefore, it belongs to case number 2. Under case number 2, it belongs to second bit. Right? If it is second bit, then t of n is equals to theta of n to the power of log a log square root of 2 base 2 into, it is case 2 second bit, right? So, n to the power of log a to the base b into log base b of log n base b. Right, friends? Okay. I can write 2 to the power of 1 by 2, bring 1 by 2 here. So, n to the power of 1 by 2. So, therefore, it will be further reduced to theta of square root of n into log base 2 of log n base 2. Clear, friends? Okay. Next question. Suppose if I consider t of n is equals to t of n by 2 plus log to the power of minus 2 base 2. Log to the power of minus 2 base 2. Therefore, verify what is a value. A is equals to 1, b equals to 2, and n power k, k value is 0, log to the power of p, p equals to minus 2. First verify is a equal to beta power of k or not. Is a equals to b power k. So, 1 is equals to 2 power 0. Yes, it is true. And what about p value? P value is less than minus 1, correct? P equal to minus 2. Minus 2 is less than minus 1, which is correct. Therefore, it belongs to second case. Under second case, it belongs to third bit. Therefore, t of n is equals to answer theta of n power log a base b, which equals to theta of log 1 value is 0. So, n power 0, that equal to 1. So, it will take only constant time. So, therefore, we successfully covered 2 cases, friends. Okay. First 4 problem belongs to first case and remaining 3 problems belongs to second case. Okay. Next, 8th problem. T of n is equals to 4 into t of n by 2 plus n cube into log n, n cube into log n. Just find the values of a, b, k. Here a equals to 4, b equals to 2, k equals to 3 and p equals to 0. P equal to 0, right, friends? Okay. Now verify the condition is a less than beta power of k or not. 4 less than 2 power 3, yes. What about p? P exactly equal to 0, so p less than or equal to 0 case. Since p less than or equal to 0 case, no, how it is p equal to 0? Please excuse me. Please excuse me, friends. So, log p, p is equals to 1 here, right? P equal to 1. So, therefore, 4 less than 2 power 3, yes, it is true. And p value is greater than 0. So, therefore, it belongs to which case? It belongs to third case. Under third case, it belongs to first one. Therefore, answer to this question is t of n is equals to theta of n power k into log power p n base b. Means from the statement of the master, then only we copy this part as it is, friends. Okay. So, therefore, whatever answer we are having here, that is only final answer here. Therefore, theta of n cube log n base 2. Clear, friends? Okay. Next question, that is the last question. T of n is equals to, let me keep it as 8 into t of n by 2 plus n power 4. Verify the condition is a less than beta power of k. 8 less than 2 to the power of 4, yes. Right. What about p value? P value equals to 0. Therefore, it belongs to case number 3, second bit. Right, friends? Okay. Then answer to this question is t of n equal to theta of n power k, n power 4 That's all. That is the final answer. So you can expect questions based on this topic in this way. There are so many questions are there in master theorem, friends. Okay, you have to practice questions like this. One time in the gate paper, they provided a flow chart. They provided a flow chart. For that flow chart, they are asking what is the worst case time complexity. If the worst case time complexity bounded by order of n to the power of alpha, then what is the value of alpha they are asking. Okay, what I'm trying to tell you, in the gate paper one time they asked the problem like this. Okay, so there is a flow chart. They have drawn flow chart like this. Here there is a recursive function a of n. Have you remembered this problem, friends? There is a conditional operator. Okay, there is a conditional operator. Suppose if it is yes, you have to move in this direction. If it is no, you have to move in this direction. Like that they mention flow chart. I hope you remember this problem. Again test in the condition. The condition is true, we can stop. I am not drawing diagram properly, so please understand this point, friends. Okay. It is one of the gate question based on this topic. Here they mentioned it is a of n by 2. Here also it is a of n by 2. Have you remembered this question, friends? In this problem, what did they ask? Suppose except recursive call, remaining all functions, okay, whatever is there here, all are taking constant time. Except recursive function, remaining all are taking constant time, order of one time. Okay. If the worst case time compressor, this problem is order of n to the power of alpha. If the worst case time compressor for this problem is order of n to the power of alpha, what is the value of alpha? And mention the value of alpha with up to 2 decimal points. So they are saying that the worst case running time for this problem is order of n to the power of alpha. Then you need to find alpha value. Okay. The worst case time compressor this problem is order of n to the power of alpha. Then what is the value of alpha? And correct that value of alpha with up to 2 decimal points. So how to solve this type of problems, friends? First assume that a of n is taking time compressor equals to t of n. Let us assume that the time required for this problem is time required to compute a of n, we are taking it as something like t of n. Then how much time is required to compute a of n by 2? It will take t of n by 2 time. So it will also take t of n by 2 times. Here also it will take t of n by 2 time. It is t of n by 2 time. Okay. So what I am trying to say, first I am defining, let the time required for a of n is equal to t of n. T of n is equals to time required or time complexity. So time required for computing a of n. Right, a of n. Since they are focusing on worst case time complexity, in this flow chart, worst case will occur only if I start from here, right? If I start from here and if I move towards right direction and moving downward direction like this. Okay, it will take more number of iterations, right, friends? Okay, it will take more number of iterations in this path. Therefore, it is taking worst case time complexity. Therefore, worst case time complexity T of n is equals to So starting from T of n is equals to, see how many times you are taking 1, 2, 3, 4. Actually, sorry for the mistake. Actually, here it is also A of n by 2. Please excuse me, because we are calling with A of n with the starting value. So 1, 2, 3, 4. And actually here one more A of n by 2 is in the gate paper. Whatever it may be. Suppose if they ask the same question, okay, if they ask same question, it is A of n by 2. We start with A of n. I wanted exact gate question, friends. Okay, sorry for the mistake, but concept remains same only. So here we are having start, right, friends? So it is a time. It is. Let me write properly. Right. So the following algorithm is computing recursive function A of n. The following algorithm is computing recursive function A of n. Then what is the worst case time compressive computing this problem? Here it is taking T of n by 2. Clear, friends? Okay. Therefore, the time required to compute A of n is equal to T of n. Then how many times T of n by 2 is there? 1, 2, 3, 4, 5. Therefore, you can take it is 5 times of T of n by 2. Remaining time we are taking constant time. The constant time means we can make it as 1, theta of 1. Right, friends? Okay. Now apply master theorem. By using master theorem, A is equals to 5 and B is equals to 2, K equals to 0 and P equals to 0. P equal to 0. Verify, is A greater than beta power of K? Yes, 5 greater than 2 power 0, which is true. So it belongs to case number 1 of master theorem. So case number 1 of master theorem. Therefore, T of n is equals to theta of n to the power of log 5 base 2, which equals to theta of n to the power of log 5 base 2 means we can write 2.32. Once it is satisfied for theta, theta is nothing but it is also satisfied for big 1 omega. Therefore, we can also say it is order of n to the power of 2.32. But they provide this value equal to order of n to the power of alpha. Now compare alpha value is equals to 2.32. Alpha value is equal to 2.32, friends. Okay, this is the way you need to process the problem. Here the provided flowchart is, the following flowchart is computing a recursive function A of n. The following flowchart is computing a recursive function A of n. To compute A of n, they are starting and every time it is splitting by half, A of n by 2, A of n by 2, A of n by 2 like this. Okay, in the beginning I have written it is A of n, right? That is not correct. A of n by 2, A of n by 2 like this. Okay, so all these cases are useful for understanding merge sort and quick sort algorithm concepts. Okay, next. Sometimes there are some situations where we can come across master theorem in this format. T of n is equals to T of n by 4 plus T of 3n by 4 plus theta of n in this format. Okay, or else T of n is equals to T of n by 3 plus T of 2n by 3 plus something like theta of n. We want to answer this type of questions also, friends. Okay, generally these problems can be addressed by using recursion tree approach. But here it is a revision class. I will explain by using shortcut method. You remember this shortcut method. Suppose if T of n is equals to T of alpha into n plus T of 1 minus alpha into n plus theta of n format, where 0 less than alpha less than 1, in that case the minimum time required for this one denoted by omega of n log n base 1 by alpha less than or equal to T of n less than or equal to maximum time required for this one is order of n log n 1 by 1 minus alpha. That is a formula, friends. Okay, now compare this problem with the first problem. Suppose if I consider problem number 1 and problem number 2. So in the first problem, what is the value of alpha? Here alpha is equals to, see, alpha, right, alpha into n. alpha value equal to 1 by 4 friends, okay. So therefore alpha is equals to 1 by 4. Clearly 1 by 4 lies between 0 and 1. 0 and 1. So hence the answer for this question is minimum time is equals to n log n 1 by alpha. N log n 1 by alpha. Since alpha is equals to 1 by 4, so 1 by alpha is nothing but 1 by 1 by 4, that equal to 4, less than or equal to T of n less than or equal to big O of n log n big O of n log n 1 by 1 minus alpha. But what about alpha? Alpha equal to 1 by 4, right? So 1 by 1 minus 1 by 4, that is 4 minus 1. We can take 3, we can say it is 4 by 3. So which equals to 4 by 3. That is the answer for the first question, okay. Minimum time is equal to n log n base 4 and maximum time equal to order of n log n base 4 by 3. And whereas in this case, what is alpha? Here alpha is equals to 1 by 3, right friends? Alpha equal to 1 by 3. So 1 minus alpha means 2 by 3. 1 minus alpha means 2 by 3. Therefore, minimum time is equals to omega of n log n base 1 by alpha. So that equals to 3 less than or equal to T of n less than or equal to big O of n log n 1 by 1 minus alpha. So 1 by 1 minus 3, 1 by 1 minus alpha, that equals to 3 by 2. So this is a shortcut method you have to use friends, okay, for finding solution for this type of problems. Do you know where we are using this type of recurrence equation? In quicksort algorithm, if we select a pivot element, if the selected pivot element placed into n by 4th position of the array, then what is the worst case time complexity of quicksort algorithm? In that case, we will get recurrence equation in this format: T of n by 4 left part, T of 3n by 4 right part, and selecting pivot element will take theta of n time by using partitioning algorithm. Okay. Similarly, suppose if the pivot element is placed into n by 3rd smallest element position, then left part is n by 3, right part is 2n by 3, and theta of n is nothing but pivot element. That we will discuss when we are talking about quicksort algorithm. Apart from that, you can remember one more problem regarding recurrence equation. Let me explain recurrence equations for remaining models also, so that it is easy to understand binary search algorithm, linear search algorithm friends, okay. Let me explain. If we consider simple loop concepts, by using simple loops, we need to construct recurrence equations, equivalent recurrence equations, and we need to address what is the time complexity for the recurrence equation. The first model which I covered in the class, suppose if I value starting from 1, I less than or equal to n, I plus plus, means I value is incrementing step by step friends, okay. If I value is incrementing step by step, then how many steps it will take to reach the target? Obviously n steps will take to reach the target. Therefore, the time required for this one is theta of n, right. You can imagine starting value equal to 1 and target value equal to n and reaching step by step. Therefore, it is taking theta of n time. So in this problem, another one is you can also express it as for I is equals to n, I greater than or equals to 1, I minus minus. Here we say starting from 1 reaching n, it means that let me explain here. Suppose I value is here, 1 is the starting value and target is n. How we are reaching this target means every time we are incrementing one step. Since every time we are incrementing one step, to reach the target, how many steps will take? N steps friends, okay. Second time what I am trying to say, you are starting from, I value starting from n, but where you have to reach, we have to reach 1. This time we are decrementing every time one step. So from I equal to n2, we are moving to n minus 1, right, n minus 1. n minus 1 to we are moving to n minus 2, like that we are coming back to starting place, like this, okay. So starting from 1 to 1 and reaching n is same as starting from n reaching 1. Therefore, it is also taking theta of n time only. Theta of n time. Clear, friends? Okay. Now, what is the equivalent recurrence equation for these two problems? Generally, in the recurrence equations point of view, these two problems recurrence equations. Generally, recurrence equation always in the form of decreasing case, because in order to meet the base condition, value of n compulsory must be decreased, otherwise we cannot reach the base condition. Therefore, recurrence equation I am writing for second one. Okay, the recurrence equation I am writing for second one, that is T of n is equals to T of how much value you are decrementing every time? You are decrementing 1. Therefore, T of n minus 1 plus, because it is starting from n, right? It is starting from n. Therefore, initially it is starting from n. Every time it is decremented by 1. So, therefore, T of n minus 1 plus 1. Okay, T of n minus 1 plus 1. What is this 1? This 1 indicates that first iteration. Okay, or you can say number of function calls. When n is equals to n, how many function call means 1 function call. After calling 1 time, input value reduced to T of n minus 1. Clear, friends? Okay, means you can imagine algorithm like this: int f of int n. If n value equals to 0 or if n value equals to 1, we can stop the process, that is written. Otherwise, else written f of n minus 1 like this. Okay, your algorithm may be looking like this. In that case, the time required for executing this algorithm, we are defining it as T of n. T of n. Then how much time it is required for f of n minus 1 means, if f of n takes T of n, f of n minus 1 will take T of n minus 1, right? Therefore, we can write recurrence equation T of n is equals to with this input n I am calling 1 time. So, with this given input n I am calling 1 time. With that 1 time I am entering the function body. If it is meeting the base condition, we can stop the process. So, I can say one function call if n value is equals to 1, right? If n value equal to 1, only one function call. Suppose if n value is greater than 1, so with this input n, we enter into function body 1 time, that is why I am calling it as 1 time. After 1 time, input value reduced to n minus 1, right? If input value reduced to n minus 1, how many function call will take? T of n minus 1. Therefore, it will take T of n minus 1. So, that is what I have written here, 1 plus T of n minus 1. Okay, if you want, I can write first 1 plus T of n minus 1. This is the equivalent recurrence equation for the first model, friends. General recurrence equation we are writing in the form of decreasing form, starting from n and reaching up to base condition. Clear, friends? Okay, the first model in recurrence equation. I hope it is clear, everybody. Second model, suppose for I is equals to 1, I less than or equal to n, but every time I am incrementing 2 steps at a time. Earlier it is 1 step, this time I am taking every time 2 steps. And if every time if I am taking 2 steps, it is taking arithmetic progression. In arithmetic progression, you can apply nth term formula. Nth term formula equals to a plus n minus 1 into d. Therefore, here if we start I is equals to 1, and if you want to reach n, it is incrementing 2 steps at a time, 1 plus 2 3, 3 plus 2 5, 5 plus 2 7, and so on, it is incrementing, right? Okay, I do not know which term it is equals to n, therefore I am assuming that it is kth term, it is called kth term. So, we can say it is the first term, it is second term, third term, it is fourth term, like that we are continuing up to kth term. Now, kth term you are taking it is n. Now, write the formula for kth term of arithmetic progression. The kth term formula for arithmetic progression Tk is equal to a plus k minus 1 into d. So, here a is equals to 1, k minus 1 into d. What is the common difference, friends? Common difference is 2. This Tk is equals to n, right? From this you need to find what is the value of k. Simplify it, so which is equals to 2k minus 2, that equal k is equals to n plus 1 by 2. means n plus 1 by 2 steps it will take to reach the target. Based on the input value, generally it is taking floor of n plus 1 by 2 steps, okay, floor of n plus 1 by 2 steps. Therefore, the time required for this one is equal to theta of n by 2. I want to keep n by 2 as it is only, okay, because if I write theta of n plus 1 by 2, 1 is a constant, I am ignoring it, I am writing theta of n by 2, keep it is theta of n by 2 only. You know that theta of n by 2, again it is theta of n only, but most of the time I am keeping theta of n by 2. The reason I will explain little later, okay, the reason I will explain little later, but as of now you can keep it as theta of n by 2, do not write theta of n, friends, okay. The reason why I am writing theta of n by 2 means, suppose if I take the same problem for I is equals to 1, I less than or equal to n, I is equals to I plus m model, I plus m, where m is a constant, okay, m is a constant where m value lies between 0 less than m less than n. In that case what happens, see, if it is constant is 2, we are taking n plus 1 by 2, n plus 1 by 2. If you apply same procedure, we will get k value is equals to n plus m minus 1 by m under floor, n plus m minus 1 by m under floor, okay, because here first term is, what is first term? First term is 1 only, common difference is m. Therefore, if I substitute a equal to 1, k minus 1 into m, mk minus m, mk minus m plus 1, from this you have to find k value, clear, k value. So, therefore, if you find k value, it becomes n plus m minus 1 by m, but you already mentioned that m value is smaller than n. So, therefore, n is dominating m minus 1, so we can make it as floor of n by m. I cannot remove m value in the denominator, because if m value increases, automatically n by m value decreases. That is why I have to give importance for the denominator also, it is n by m, right, friends, okay. So, if it is n by m, obviously it is n by 2, that is the reason I kept 2 as it is only, okay, right. In these two models, okay, we can also write it as starting from I value starting from n, as long as I value greater than or equals to 1, I can subtract some constant value m like this, constant value. Just observe this model, starting from 1, reaching n, every step by adding m is same as starting from n, reaching 1 by subtracting m every time. Am I right or wrong? The way how I explained here, same thing. Starting from 1, reaching n by incrementing I 1 by 1 is same as starting from n, reaching 1, decrementing 1 step at a time, right, friends, okay. So, therefore, it is same as I equal to n, I greater than or equal to 1 and I equal to I minus m. As I mentioned, the distance between from my home to your home is same as the distance between your home to my home, right, in the same way it is also, okay. Is it clear, friends, okay, right. In these three cases, when you are talking about recurrence equation we are writing only if value of I is decrementing, right. Therefore, here I can write recurrence equation, that is T of n is equals to, first let me write recurrence equation for this simple part, okay, okay. Give me 1 minute time, friends, okay. Here we are writing for I is equals to n, I greater than or equals to 1, I equals to I minus 2. So, then the recurrence equation for this one is T of n is equals to 1. What is the purpose of 1? First function call, okay. It is a first function call, therefore, I am taking it as 1. After first function call means your algorithm is looking like this, int f of int n, if n is equals to 1, control return to operating system. If this condition fail, then return to f of n minus 2, clear, friends, f of n minus 2. In that case, the time required for computing f of n, I am taking it as T of n. You know, recursive algorithm time complexity always bounded by the total number of function calls, right, Therefore, f of n takes how many function calls? T of n function calls, that is why I am taking T of n. With the input n, I am entering into function body first time, that is why I am counting it as one call. With the input n, I am entering into function body first time, that is why I am calling it first function call. If it is meeting the base condition, you can stop the process. In the worst case, we had to assume that it is not meeting the base condition, then we had to enter into else part. Then f of n takes t of n, then f of n minus 2 takes t of n minus 2. Am I right? So therefore, it is t of n minus 2. Just to compare these two, friends, you are starting from n, reaching 1, and every time you are subtracting 2. You are starting from n, reaching 1 because base condition is 1, and every time you are subtracting 2. Are these two are same or not? Yes. Therefore, the equivalent recurrence equation is 1. Both the cases time complexity is theta of, yes, just now explained, right? If it is I minus 2 means you have to take it as n by 2. So, theta of n by 2. Is it clear? Theta of n by 2. This is the equivalent recurrence algorithm. Then suppose if I take another case like for I is equals to n, I greater than or equals to 1, I is equals to I minus m. Right, friends, I minus m, which is same as this model, right? Which is same as this model. So 1 plus t of n minus m, 1 plus t of n minus m. Then what is the answer for this one? That equal theta of n by m, theta of n by m. So it is second model which I explained in simple loops. First model completed, second model completed, friends. Okay.